right? To look at element C. Okay. So when you go under the shaft to look at element C, this is what you get. Okay. So if I go below now, okay. So look at the look at the transformation. Okay. Why is V pointing down? It's just arbitrary. Okay, it can pointing from left side, it can be pointing from right side, it can be pointing from downside. I'm just giving an arbitrary example. Chike Zibiri. Okay, right. So now I'm looking at element C in a position that I have to be underneath. Okay, so when that's the case, this is my point X still, and then I'll let you see the transformation. This is point Z. Okay. So when I look at the shaft now looks like this. Okay. And this is the axis. And this is the element. I'm drawing the element big deliberately. Okay. So this is my element C. Okay. This is my element C. So when this is the case, right? Now you see element C, right? When this is the case, the torque will be acting in this direction. Okay. So the torque is this torque I'm highlighting now. So this is my TX. Okay, that's my torque, which is 2,300 pound-feet. Now I'm not converted anything yet. Okay, I just want to do, we just do the analysis. Later on, we start converting. That's our TX. Okay, right. So when that's the case, right, how will the element deform? Okay, so the element will deform this way. Now this is exaggerated deformation because now your shear stress act this way, yes or no? So this is going this way. So the element will deform this way. Now we just apply Mohs circle on element. Okay. So if you look at this, okay, if you look at this now, right? Right. I want you to recap. If I draw my element now, right? So for positive shear, right, is going this way. The element will deform in this direction. Right? Positive shear. Okay. And then for negative shear, the element will do this. So if you look at how our element is deformed, we realize that this is what? This is negative shear. Okay. Now, later on, I'll tell you in what situation this is very important, in what situation that's not important. Okay. Why are all the axle loaded given in negative? This is because the axle force is going in compression. Iran, is that your question? Okay, Iran. So because the 2,500 is all negative. Okay, thank you, Iran. Right. Okay. So now we're going to draw our 3D element now. Okay, now we're going to draw 3D. Okay, so some of you might say, okay, why are we looking at the 3D element? Okay, so the next thing we're going to draw. Okay, so now we know we know which element we're going to investigate. Okay, so we're going to plot or draw 3D element and 3D mode circle. Why are we doing this? Okay, to determine the maximum diameter of mode circle, of 3D mode circle. And we know, right, in 3D mode circle, we have 3 circles. How do you know yours is not the smallest, the middle circle, or the largest circle? You have to know, okay? You have to know. Now, this is where, when I was an expert witness in another case, the engineers got it wrong, okay? One case is they analyzed the wrong element or the position where higher stress occur. Another case is where they did not use the biggest diameter of the 3D mode circle, okay? Right. So now we have to do this now, okay? So we're going to draw the 3D element in element C. So again, we're looking at element C. Okay, where we're still focusing. So now I use the same transformation as here. Okay, I'm going to use the same transformation, and we're going to look at element C. Okay, so here we go, element C. I'll draw it slightly curved. Okay, not too curved because element C is a small element. Okay, so if I will construct our transformation X, Y, and Z. Okay, and I'm going to draw the outer surface or draw hidden line because it's the outer surface we're going to look at. Okay, so we know, right? We are aware there is a normal stress coming in, stress X. We know that we are going to see shear. Okay, so this is our shear intersecting plane. Sorry, this is shear XZ. This is shear ZX, right? And we know there's a shear there, okay? Then now I'm going to label 3D mode circle point location, okay? So this is my X. This will be my, this will be my Z, right? And the circle or the surface that is on the other face, the under face, okay? This is my point Y. So what we know that stress Y is equal to 0, okay? And the shear is also equal to 0. There's no shear acting on Y, right? No, yes. Okay. So now we are going to sketch our element. This is just a sketch, okay? To determine where the maximum diameter is, okay? So we draw this. So this is our normal stress. This is our shearing stress. Right? So what we are aware now, okay, so I think I'm going to draw this bigger. Okay, we're going to draw this bigger. So element rotate clockwise, element rotate anti-clockwise. So we know that stress Z, normal stress Z and normal stress Y is equal to 0. So stress Y and stress Z line are on that vertical. But stress X, we're going to have a compression. Okay, stress X equilibrium compression. So we know that point Y is definitely down here. Okay, we know that point Y because there's zero normal stress. That belongs to point Y. Okay, but we have some shears going on. We got shearing going on. So we have shearing. Right. So if you look at your 2D orientation down here, right, or if you look at what we have down here, okay, so to do this, you have to bring it back to you have to view from here now. Okay, you have to view from here, right? So this is your point Z, this is your point X. Okay, so your point Z is doing a clockwise rotation. No, anti-clockwise rotation. So point Z is here. And then point X is over here. Okay. Then you draw the line. Okay. So over here then, go on. So we know where our center of circle is. Now this is a sketch, okay? I highlight again, this is just a sketch. Okay, so that's our center of circle. Now we can draw more circle. Okay, again, I'm telling you this is just my sketch. All right, okay. So we know now this belongs to our XZ plane. Okay, right? And then we have another circle, right? We have another circle. So remember, there are 3 circles or more circle, yes or no? So we have another circle over here. Now, XZ plane is our in plane because the surface area is the biggest, right? It's our in plane. Okay. So XZ plane is this plane we're talking about. Then the next circle that I can only sketch, this is your YZ plane, out of plane. And then the next circle, 6 and a bit. I'm just sketching this, okay? There is your third circle. So the third circle, this is your what? This is your XY plane. And again, this is your out of plane. Right? So you can label now this is stress A. Over here is your stress B. Okay, or you flip it over, does not really matter. Okay, so now once you got this, like what I want to tell you, right? Like what we wanted to do in the very beginning, we want to see where is the maximum shearing stress. Okay, where's the max? So the maximum shearing stress is here. So now we know the actual position. So this, sorry, is our tau XZ or tau max XZ. And this is the tau max. Okay, we have to use this value. There's no other value that we can use. Okay, so this, we happen to be lucky for this case. What do I mean by lucky? You can also use 2D Mohs circle to find the same thing. Am I right? Yeah, but what if Remember what I taught last week, right? What if it's not the bigger circle? What if in a situation that what you're calculating is the